Okay, so find this page in your notes. This page says end behavior model. Okay. So the definition says the function g of x is ... and you have these three. G of x is a right end behavior model for function f of x if and only if the limits as x approaches positive infinity of your f of x divided by g of x equals to 1. Okay. So g of x is a right end behavior model for f if when we take the original divided by g of x, it equals to 1. So g of x is a left end behavior model for function f of x if and only if the limit as x approaches negative infinity of f of x divided by g of x equals to 1 again. What the heck does that mean? Do you guys remember learning the end behavior back in the day? So algebra 2? Okay. No? When you guys were studying functions, and then you said, what's the end behavior? Do you guys remember going to the right and the left? And we say either up, up, or up, down. Remember those terms at all? So if you have y equals x squared, what was the end behavior? It's either up and up, right? That's a positive. And then you have a cubic, y equals x to the third. What was the end behavior? Yeah. So that's what's happening. Same thing with this. But instead of saying up, up, and up, down, up, whatever, we're saying, hey, x is going all the way to the right, okay? G of x is the right end behavior. But if you take the original, and then you divide by g of x, it should be very, very close to 1. Limit is talking about something getting closer and closer. And the left end behavior is if it's going all the way to the left side, like a negative 1 million, when we take the original function, we divide by g of x. If it's close to 1, then g of x is the left end behavior. Now the third case is just called an end behavior period. Okay. Just called an end behavior. There's no left and right. End behavior model if left and right are the same. So this is what I mean. Let's make up something, like i.e. f of x is positive 3x to the fourth minus 100x squared plus 9. I have no idea what that looks like. Now, if we take the limit, okay, as x approaches 1,000,000, what do you think the y is going to be? Where you would think, where is y? Yeah, straight up, right? Really, really steep. So what it's saying is that, okay, well, when I take the limit as x approaches something super big, I have f of x, which is given, made up, divided by g of x. I want something to be super, super close to 1. So what do you think g of x has to be for us to be super, super, super close to 1? When we approach 1,000,000, 10 millions, and so on and so on. what would g of x have to be? So 3x to the 4th minus 100x squared plus 9. Divided by what? So this is going to be close to 1. That's technically true, okay? Technically, if I just kind of shave off a little bit, right? Then I'm getting closer and closer to myself. Remember, you can only divide by yourself to get 1. Would you guys agree? But, again, I'm getting super close to a million. What happened to these terms? Are they relevant? Not really. The bigger number we get closer to, everything else behind here would not be relevant at all. So if you have Bill Gates money, you're going to come to our school, give everybody $1,000, he is still pretty darn rich. So when you're so loaded, these don't matter, right? So g of x is just simply what? 3x to the 4th. So for this one, your right end behavior is just simply 3x to the 4th. So the end behavior is the simple, okay? When I say simple, it's usually one term that's representing the more dominant of the polynomial. Any questions on the end behavior? Okay, let's practice some more. For each function, find a power function and behavior model. Power function and end behavior model, by the way, they're exactly the same, okay? And then identify if you have any horizontal asymptote. 6a, first, end behavior. Do we have one? What would g of x be for this one? As x approaches infinity, what would g of x have to be? So when we take negative 4x to the 3rd plus x squared minus 2x minus 1 divided by some g of x, it reaches or it's close to 1. So what's the more dominant term for this?
Negative 4x cubed.
That's right. So that's negative 4x cubed. That's all we have to worry about. This is a polynomial. So does it have any asymptote? Do we have any horizontal asymptote for polynomials?
No.
No. So this one, no HAs. Okay. B, similarly, is now a rational function. Do we have an end behavior model? What's the dominant term on the numerator? 3x squared. What's the dominant term on the denominator?
X squared.
X squared. Can we reduce? Good. So your g of x is going to be? 3. That is your end behavior model. What does that really mean? That seems so funky to have that. What does that even mean, guys?
You a horizontal line in 3.
Yeah. That means like if I graph this out on Desmos, okay, and stretch or zoom in or zoom out, I should say, it's going to get more horizontal as we go right, and it's going to get more horizontal as we go left. That's what it means. Okay. So it's going to get super horizontal close to 3 when we look at like x at a negative million or a positive million. Okay. And then, do we have any asymptote? I mean, this can say horizontal asymptote. Back in the day, do you guys remember how to find horizontal asymptote?
No.
That's the vertical asymptote. How do we find the horizontal asymptote? Take the leading term on the top, divide by the leading term on the, well, isn't that the same thing? Yes or no?
How can this find the horizontal asymptote? How can this find the asymptote?
I know, right? Why is this, by the way? I know. Let's go back to the, oh yeah, it's magic. Math is magic. Remember, the definition, which, by the way, I can't scroll down because obviously we didn't have this computer the other day. The definition of horizontal asymptote was the limit, what? What was the definition? The limit?
As x approaches infinity.
as x approaches infinity of some function, right? It must equal to what? It must equal to? What's the definition of HA? Okay, if x equals b, or would you agree that I can also approach negative infinity, right? Or limit as x approaches negative infinity of some function equals to b. If that's the case, HA is y equals to b, all right? Isn't that the same definition as end behavior? Okay, wouldn't you agree that's the same definition end behavior? End behavior said as x approaches some ginormous number, right? So that's why g of x is the end behavior as well as the HA. Okay? Because they're both talking about the extreme values to the right or extreme values on the left. All this is saying that, hey, if we graph this out, when we get to 1,000, it's going to be very, 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 very close to 3. Very horizontal as we get. Remember, and also definition asymptote is when the graph approaches as well, right? So sometimes it can touch the horizontal, sometimes it can't. But it doesn't really matter. It always get very, very close to your horizontal asymptote. So that's why end behavior and horizontal asymptote are the same. Okay, this one, not so much. For your function y equals x squared plus e to the negative x, find a simple basic as a right end behavior model for your functions. And I'm looking for the right end behavior. So by definition, would you agree that's right end behavior, meaning I'm approaching positive infinity? You already have f of x, which is x squared plus e to the negative x. Now I'm looking for g of x. When I divide those, I should equal to what? 1, right? So, what would g of x be?
X squared.
How do you know?
Because x squared is the dominant group.
Do you guys agree with Michael? That's okay to disagree. Let's pick, i.e., my infinity number is 1,000. Would that be okay? When I plug in 1,000 square. So 1,000 square versus e to the negative 1,000. Which one is going to be more dominant? 1,000 square. Because isn't e to the negative 1,000 is kind of like this? That's really getting closer and closer to what? 0. So for this one, the right end behavior model is x squared. Now how about left end behavior model? So definition says, limits as x approaches negative infinity. Again, we're using the same f of x, so x squared plus e to the negative x divided by some function, let's call g of x. So left end behavior is g of x. What is it now? Give me your infinity number. What's your infinity number? As we're approaching the negative side. What's your infinity number on the negative side? Sure, negative 100, negative 1,000, doesn't really matter, i.e. Okay, 1 is not an infinity number. You want to make it as big as you can.
2.
Okay, so question number 1. Term number 1 is x squared. So negative 1,000 quantity square versus e to the negative of a negative 1,000. Which one is more dominant? Exponential growth is always much, much quicker. So the left end behavior model is e to the negative x. Do you guys see the difference between those? Can you see that not always the same? Okay. Let's do one more. You're given x squared plus sine of x. Give me the right end behavior model. What do you think? What would that be? G of x is?
X squared.
So, would you guys agree with that statement? Okay, x squared. right? How about left? What would that be? Same? Would you agree with that? Why is it the same? What's the highest the sign's going to get to?
1.
Exactly. What's the lowest?
-1.
-1. And you know what? One of my students brought this up, and I want to make sure we agree. So i.e., instead of x squared, what if I give you y equals x plus sine of x? Okay. What's the right end behavior model? It's x, right? What's the left end behavior model? Is it sine of x or is it still x? Still x. Why would that be? Okay, remember when we divide f of x, right, the limit, when we divide this function, it has to be divided by something, so that way your output has to be 1. So if I pick like a -1000, would you guys agree with that statement? Sine x can only be either positive or negative 1. Positive or negative 1 divided by -1000, is that ever going to give me 1? No. So that's why if we pick a -1000, this has to be a -1000. And -1000 divided by -1000 equals 1. So that's why even if I change to x, your end behavior is still x for both. So does it have to be positive? That's my question to you. No, right? The height doesn't have to be positive. Would you guys agree? The output, as long as we take the height and divide by each other, it equals to 1. Look at this, it's -1000 if we pick -1000. So the height in the top is -1000 because we're picking -1000, okay? Okay, last question of today, and then I'll let you free for homework. Piecewise always been a little bit more difficult because there are 2 components, or in this case 2 components. Find the limits of your function. So the first one is find the limits as x approaches -infinity of your piecewise. So out of the 2 pieces, which piece are we using? Which one even approach -infinity? The first, right? So here's the first, so x minus 2 divided by x minus 1. So what's the answer? As x approaches -infinity, what is the height getting closer and closer to? 1. How do you know? Yeah, take the leading term of each and divide each other, so you get 1. B, find the limits as x approaches positive infinity now. Out of those 2 pieces, which one will be on the right side? The bottom. You're right. So 1 over x squared. Now be very careful. What's your answer? X approaches something super big, like 1,000. How do you know? Yeah, because if you were to pick 1,000, i.e., would you agree that it's really 1 divided by 1,000 square, which is super, super close to 0. So that's 0. Okay. Next, limits. Find the limits as x approaches 0 from the right. Whoa, which piece? Bottom, right? So would you agree the bottom is from 0 all the way to the right? So that means if I'm coming from the right, I have to use the bottom piece. So that's going to be 1 over x squared. What's the answer? Is it 0? No? I can't substitute 0. What are we going to think? Substitute 1, something closest to 0 on the right side. 0.000001, right? Something super tiny positive. So we're going to pick point whatever. Pick as many zeros you can write. What happens? It gets really, really big, right? Because 1 divided by something square. Would you agree? This whole thing square. That's even bigger than my original. Then 1 divided by something so small, it's going to get really, 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 really big towards infinity. I'm going to hold it right there so you can ask me. And then last one. You try. Decide on a piece. Are you going to use piece 1 or piece 2? Piece 1, okay. For this one, can we use substitution straight up? Yep. So once you use substitution straight up, what's your limit? 2. Box it up. That is your egg roll for today.